let's say that f of x is equal to x plus 7 to the third power minus 1. And let's say that g of x is equal to the cube root of x plus 1, the cube root of x plus 1 minus 7. Now what I want to do now is evaluate f of g of x. I want to evaluate f of g of x. And I also want to evaluate g of f of x. G of f of x and see what I get. And I encourage you, like always, pause the video and try it out. All right, let's first evaluate f of g of x. So that means g of x, this expression is going to be our input. So everywhere where we see an x in the definition for f of x, we would replace it with all of g of x. So f of g of x is going to be equal to, well, I see an x right over there, so I'd write all of g of x there. So that's the cube root of x plus 1 minus 7, and then I have plus 7 to the third power minus 1. Notice, wherever I saw the x, since I'm taking f of g of x, I replace it with what g of x is. And so that is the cube root of x plus 1 minus 7. All right, now let's see if we can simplify this. Well, we have a minus 7 plus 7, so that simplifies nicely. So this just becomes, this is equal to, I can do it a neutral color now. This is equal to the cube root of x plus 1 to the third power minus 1. Well, if I take the cube root of x plus 1 and then I raise it to the third power, well, that's just going to give me x plus 1. So this part just simplifies to x plus 1, and then I subtract 1. So it all simplified out to just being equal to x. So we're just left with an x. So f of g of x is just x. So now let's try what g of f of x is. So g of f of x is going to be equal to, I'll do it right over here. This is going to be equal to the cube root of, and actually let me write it out. Wherever I see an x, I can write f of x instead. I didn't do it that last time. I went directly and replaced with the definition of f of x. But just to make it clear what I'm doing. So everywhere I'm seeing an x, I replace it with an f of x. So the cube root of f of x plus 1 minus 7. Well, that's going to be equal to the cube root of f of x, which is all of this business over here. So that is x plus 7 to the third power minus 1, and then we add 1, and we add 1, and then we subtract the 7. Lucky for us, this subtracting 1 and adding 1, those cancel out. And so we're going to take the cube root of x plus 7 to the third power. Well, the cube root of x plus 7 to the third power is just going to be x plus 7. So this is going to be x plus 7. So all of this business simplifies to x plus 7. And then we need to subtract 7. And these two cancel out, or they negate each other, and we are just left with x. So we see something very interesting. F of g of x is just x, and g of f of x is x. So if we, in this case, if we start with an x, we input it into the function g, and we get g of x, and then we input that into the function f, and we put that into the function f, f of g of x gets us back to x. It gets us back to x. So we kind of did a round trip. And the same thing is happening over here. If I put x into f of x, if I put x into put x into the function f, and I get f of x, the output is f of x, and then I input that into g, into the function g. Once again, I do this round trip, and I get back to x. Another way to think about it, if you view this as, so these are both composite functions, but one way to think about it is, if these are the set of all possible inputs into either of these composite functions, and then these are the outputs, so you are starting with an x, I'll do this case first. So G is a mapping. Let me write down. So G is going to be a mapping from x to g of x. So this is what G is doing. So the function G maps from x to some value g of x. And then if you were to apply f to this value right over here, if you apply f to this value to g of x, you get all the way back to x. So that is f of g of x. And vice versa. If you start with x and you apply f of x first, so if you start with f, if you apply f of x first, let me do that. So if you apply f of x first, you say you get to this value, so that is f of x. So you applied the function f, but then you apply the function g to that. You apply the function g to that, you get back. So this is g of f of x, I should say. g of f. We're applying the function g to the value f of x. And so since we get a round trip either way, we know that the functions g and f are inverses of each other. In fact, we can write that f of x is equal to the inverse of g of x, and vice versa. G of x is equal to the inverse of f of x, Hope you enjoyed that.